In this video, we're going to be solving practical problems on partial fractions. So let's say we are given this fraction and we have to resolve it into partial fractions. How do we go by it? First things first, we have to determine the type of fraction it is. Is it a proper fraction or is it an improper fraction? If it is a proper fraction, then the degree of the numerator must be less than the degree of the denominator. And if it is an improper fraction, then the degree of the numerator must be greater than or equal to the degree of the denominator. Now for this particular question right here, we notice that the degree of the numerator is 0. That is how come we have a constant here. And the degree of the denominator is 2. One from this x and the other one from this x as well. So now that we know that this is a proper fraction, we can go ahead and then decompose it. So what I'm going to do is that for this particular question, you notice that we are going to have two different fractions being separated by addition sign. Cool. Now for this first fraction, the denominator is going to be the first factor right here, which is x minus 3. Then for the second fraction, the denominator is going to be x plus 3, which is this factor right here. Now, what are we going to put right here? Now, if you haven't checked on how to set up partial fractions, I recommend you go to the description down below. The video is there for you to watch. So, for this particular fraction, the numerator is going to be a constant because we know that for partial fractions, the degree of the numerator must be 1 less than the degree of the denominator. So if the degree of the denominator right here is 1, it means that the degree of the numerator is x to the power 0. And we know that x to the power 0 is 1. 1 times a will give us a. In the same way, we also have a linear factor right here. Therefore, the numerator must be a constant. So let's let b be that. Cool. Now, how can we combine these two fractions to form one fraction? The easier way to do that is to multiply the numerator and then the denominator by this factor right here. And in the same way, I have to also multiply the numerator and then the denominator by this factor. And if I do that, I'm going to end up getting the left-hand side will still remain the same. So x minus 3 times x plus 3. And this is congruent to, we have a times x plus 3, then plus b times x minus 3, all divided by the product of the two denominators, which is going to be the LCM, x minus 3 times x plus 3. There we go. Now you notice that the denominator right here is the exact same as what we have here. Now to get rid of these denominators, we have to multiply each side of the equation by the exact same factors. And if you do that, you realize that they will cancel each other and we'll be left with 6 is congruent to a times x plus 3, then plus b times x minus 3. Now how can we get a and b from this equation that we have here? Now what I'm gonna do is that I'm gonna put x equal to 3, and if I do that, you notice that the whole of this term will disappear. So we are going to end up getting 6 is equal to a times 3 plus 3, then plus b times 3 minus 3. Cool. So from here we see that we are going to have 6 is equal to 6a. Now you notice that the whole of this will go to 0, and this is what we have now. And basically we have a is equal to positive 1. That is when we divide each side of the equation by the coefficient of a, which is 6. Cool. Now how can we figure out the value of b from this equation? The second thing I'm gonna do is that for this one, I'm gonna put x is equal to negative 3. Why? Because if I replace all the x's with negative 3, this whole term right here will go to 0, and I'll get b from that. So we're gonna have 6 is equal to a times negative 3 plus 3, then plus b times negative 3 minus 3. And we are going to have 6 is equal to negative 6b, because the whole of this will go to 0. And you notice that for this particular equation, b is equal to negative 1. That is when we divide each side of the equation by the coefficient of b. So ladies and gentlemen, I'm going ahead and then I'm going to replace the b with what we have for the b, and that will be 8. b gave us negative 1 whilst a gave us positive 1. So I'm going to have to put positive 1 right here, and that will be 8. So this right here could also be written in different forms since this negative will affect the whole of this. So our final answer is going to be 6 divided by x minus 3 times x plus 3 is congruent to 1 over x minus 3, then minus 1 over x plus 3. And that's it. Now, this is our next example. Let's go ahead and then resolve this into partial fractions. Feel free to pause the video and give it a try first. I notice that the degree of the numerator is 1, whilst the degree of the denominator is 2. As long as the degree of the numerator is less than the degree of the denominator, we are good to go. But before we start decomposing this fraction, you notice that on the denominator side, we have quadratic expression, which is not factored. So we have to factorize this before we can express it in partial fractions. Now, this denominator right here is a quadratic expression where the leading coefficient of the x squared is just 1. If this happens, then we have to focus on the constant right here, which is negative 3. What are the two factors that their product will give us negative 3, but their sum will give us this positive 2? That is pretty much easy. Positive 3 and negative 1. I'm going to replace these 2x with these two factors, and this whole quadratic expression is going to be x squared minus x plus 3x minus 3. Then from these two first factors, we can just take x out. Then we have x minus 1. Then from the remaining two terms right here, we can just take positive 3 out, and we'll be left with x minus 1. You notice that x minus 1 is common, so I'm going to have to factor that out, and we are left with x plus 3. So this means that the whole of this quadratic expression right here could be replaced by what we have right here. Cool. So I'm going to get rid of this really quick and then replace the whole of this with this factor. So this is the same as 11 minus 3x all divided by x minus 1 then times x plus 3. And now we can decompose this into partial fractions. Of course, we'll end up getting two different fractions. Of course, the first fraction will have a denominator of x minus 1, which is this factor right here. Then the second fraction will have a denominator of x plus 3. There we go. But what are we going to put right here? You notice that in either case we have linear factors. Therefore, the numerators are going to be constant numerators. So if this is a, then of course I'm going to have to set this one to b. And the next thing is to determine the values of a and b, and that will be 8. So what I'm going to do is that I'm going to combine these two fractions to form one. This is going to be, of course, I would like to keep the left hand side, which is 11 minus 3x all over x minus 1 times x plus 3. Cool, and this is congruent to, now you notice that for this particular two fractions, the denominator or the LCM is going to be x minus 1 times x plus 1. That is the product of the two denominators will give us the LCM. Then this a will be multiplied by this, so this is going to be x plus 3 multiplying a, then plus b also multiplying this denominator, which is x minus 1. There we go. Now you notice that this denominator right here is the same as this right here. If we multiply each side of the equation by the exact same denominator, they will cancel each other, and you see that all these denominators will disappear, and we'll be left with just 11 minus 3x, and this is congruent to a times x plus 3, then plus b times x minus 1. Now what I'm going to do next is that I'm going to ensure that one of the terms will go to 0 by just putting x to be equal to positive 1. If I put x is equal to positive 1, we're going to have 11 minus 3 times x is 1 now, so it's going to be just 8. So the whole of this will be 8, and this is equal to a times this is going to be 4. So we're going to have 4a, and the whole of this will go to 0. And if we divide through by 4, we are going to have a is equal to positive 2, and that will be 8 for a. Now again, if I want this whole term to disappear, then that means I'm going to have to put x to be equal to negative 3. And if I do that, I'm going to have 11 times 3 times negative 3. That is going to be positive 20. So I'll have positive 20 on the left hand side. Then on the right hand side, the whole of this will go to 0. Then we have negative 3, negative 1. That will be negative 4 times b. We are going to have negative 4b. And if we divide this side of the equation by 4, we will end up getting b is equal to negative 5. And if we go ahead and then replace both a and b with their respective values, for this one here, we are going to have the numerator to be positive 2. Then for this b right here, this is also going to be negative 5. But you notice that this negative will affect this positive sign. So I'm going to have to get rid of this and then replace that with negative 5. And this is the answer to the problem. So guys, that is pretty much it for today. I believe you found the video useful. Make sure you give me a thumbs up, subscribe to the channel for more, and see you again on the next video. Have a nice day. Take care. Bye bye.